This week we're covering probability and sampling, which are chapters 4 and 5 in the textbook. This material is a bit more technical than the material we covered last week, and perhaps a bit harder, but it's really the core of statistics, so it's very important that we study this material. The main topic's probability. We won't cover a lot about sampling. Even if you look at the textbook, chapter 5 is a bit shorter. And all the tutorial questions will be about probability and most of the lecture. So what is probability and why is it important? Probability is a logical approach to dealing with risks, chances and uncertainty. And it's important for a couple of reasons which are relevant to environmental studies, environmental management. First, we want to understand how we can think about the likelihood of events taking place. Often in environmental management, we're thinking about natural hazards like floods or volcanic eruptions, hurricanes, earthquakes, etc., and trying to understand the risks of those and the risks of certain types of damages is useful. So we need to understand probability from that perspective. But for the remainder of this course and the assignment you're going to be doing for the course, the main thing is to understand about uncertainty in data, and there are various reasons why data are uncertain. One is that our measurements maybe aren't very good. We have error in measurement, inaccuracy, and another reason could be purely that there's randomness in the world and things don't follow sort of deterministic clockwork kind of processes, and we need to take that into account when we do the analysis. And finally, probably the most important is we've got perhaps good measurements on the data, but we have a lot of uncertainty about what is actually happening, what the true model is, and we need to be able to model that uncertainty, and therefore it's very important to understand probability, as it's the simplest approach at least to modeling uncertainty in models and data. What else? So when you're looking at the textbook, as I've mentioned on the web page, you can skip Bayes' theorem that's in chapter 4, and you can also skip the discussion of the break-even effect in chapter 5, which is something about poker. And I don't know, maybe some of you understand this games better than I do, but I didn't really get a lot out of that, so you can skip that. The test. The on-campus students, sorry, we're going to have a test this week, as it says in the outline. On-campus students will do this at the beginning of the tutorial session, and it'll be actually, I'll hand you out a one-page hard copy with questions, and you'll write your answer on that page. And online students will try to post it as a quiz or an assignment online. I'll update you more on that as we get nearer to the date. I'm making this video a couple of weeks ahead. And what I'll ask you is, I'll just give you some output from Stata program related to something we did in the previous tutorial, but a little bit different. And I'll ask you to interpret the results you see there on the page. And I want you to explain what it really means. I can see what the numbers are, so I don't want an answer like the standard deviation is 0.4. Well, what does that mean? Does that mean that the variable is very varying or not very much? What do you think about that? And if I ask you about perhaps relationship between two variables, do they have a strong relationship or not a strong relationship? That's the kind of thing I'll be looking for in the answer to the question. So I'll just get you to answer a few points about output from a Stata program. Okay, shouldn't be too hard, shouldn't take up too much of a tutorial. I've already posted the questions for both the first tutorials online, so you can get an idea the kind of things we'll be doing there. Okay, I'll look forward to seeing you lectures and the tutorial.